Okay. Now, for the following two examples, I don't need to explain here. I already specify and explain everything here for you, so you can look at solution and follow it, practice it. Okay, so I'm not going to talk about the two examples here, but make sure you read it. They're very important. Now, I want to talk about application, okay? So we use the system of two equations to solve real-life applications. So here's the example. It's called soccer field. The perimeter of a soccer field is 340 meters. The length exceeds the width by 50 meters. Find the length and the width. So, what we need to define is length and width, okay? Okay, so to solve this, let's come up with the variable, because we don't want to use the whole term length as the variable. I mean, we can, but it look very complicated to solve the equation. So let L be the length, okay, of the soccer field. Let W be the width, okay, of the soccer field. Now because P is perimeter, right, is given. So let P be the perimeter of the soccer field. Now we're given that the perimeter of a soccer field is 340, so we know that P is equal to 340 meters. Okay. The length exceeds the width by 50 meters. Now, if we can translate that statement, the length exceeds. See, the length exceeds the width by 50 meters. Okay. When you convert this statement, you should get the length mean L, right? Exceed the width mean the length is longer than the width. So exceed the width. So if you take the difference, check out to the length, subtract the width, you should get 50 meters. Okay? So far we got one equation. Length subtract the width, 50 meters. Now remember, to solve an equation of two variables, you need minimally two equations. So if an equation has two variables, you need two equations with the two variables, similar variables, to solve those two variables. So far we only get this equation, which is L subtract W for 50. We need one more equation so that we can find L and W. Without the second equation, we cannot solve. Okay? So how do we find the second equation? Let's read the question again. The perimeter of a soccer field is 340 meters. The length exceeds the width by 50 meters. Now we took care of the statement. The length exceeds the width by 50 meters. How about the statement? The perimeter of a soccer field is 340 meters. Now, if you recall from geometry, which color? For example, this is the soccer field, okay? It's a rectangle. It has a rectangular shape. So let's call this the length, this is width. So the width length is longer in this case, so I pick it longer. Now, you recall, perimeters of a rectangle is the sums of all the length of all these width, okay, and length. You saw that. There's another width up here, right? And there's another length here, right? Perimeter is the length around the rectangle. So that means you need to add, right? L. You need to add the length of this much, which is L, the length of this much, which is W, the length of this much, which is L. You need to add the length of this much, which is W. So you just found the perimeter around the rectangle, which is L plus W plus L plus W. Okay. Simplify by combining line term L plus L at 2L plus W 2W. Okay. Now, we're given P, which is 340 meters. You can replace P with 340 meter. Look at that. You are actually having the second equation. This is the first equation. Okay. This is the second equation. Now, to solve an equation with two variables, you need minimally two equations with the same two variables. LW. That's a good sign. Now you actually can solve L and W. Now, before we go further, look like we can simplify this second equation, right? Because it's even number, even. Look like we can divide by 2 and make this second equation look nicer. Okay, so let's divide both sides by 2. 340 divided by 2. 2L divided by 2 plus 2W divided by 2. What do we get? 170 L plus W. 2 divided by 2 by 1. 1 times L is L. 2 divided by 2 is 1. 1 times W is W. So, again, let me call this equation 1. And equation 2, let's call this one. It's a simpler form. You can use this form, but let's use this one because that's smaller numbers. It's easier to deal with. Okay, so call this one equation 2. Okay. Now, how do we solve these two equations using the substitution method? Remember, for the substitution method, you need to solve for one variable, x equal to whatever, or y equal to whatever. In this case, we have LW, so you need to pick one variable to start with, either L equal whatever, okay, in one equation, and substitute L equals something in that equation into the other equation, and then you can solve for W. Or you can select W equals something and in one equation, and then substitute W equals that to the other equation and solve for L. So, you have a choice. You can pick either one of the two equations. Let's pick equation 1 to start with. Okay, so for equation 1 we have L minus W equal to 50, equation 1, right? Let's solve for L, okay? You can solve for W, but it's easier for this case to solve for L because L already positive. W is a negative term. That means you need to convert this negative W to positive W. So it's better efficient to start with L. So to solve for L, add W on both sides. This is equation 1, okay? Simplify, we get L equal to 50 plus W. Alright, now from equation 1, you got L equal to 50 plus W, which is also equation 1, but just written in a different form. Substitute this into the second equation, okay? This is the result of the first equation, so you substitute this to the second equation. Do not substitute this to the first equation again, because this is the first equation, alright? Because you want to make the two equations intertwine, okay, or intersect to see how they are, so that you can eliminate, simplify, and find for the two variables. Make sure you want to have the interaction between the two equations. So this is the equation 1. So substitute equation 1 to equation 2. Okay? So I'll substitute L right here into this L in equation 2. So we have equation 2, 170 equal L plus W. I'm going to substitute L from equation 1 to equation 2. 50 plus W, and then simplify. 170, 50 plus W is 2W. Subtract 50 on both sides. Now, subtract 50 on both sides. I'm running out of space, so let me make it quick. So I'm going to subtract 50 on both sides. Okay. If you subtract 50 on both sides, you should get 170 subtract 50, which is 120, equal. So let's continue, okay? 120 equal to 50 subtract 50 is 0, plus 2W. Okay, simplify, we have 120 equal to 2W, then divide by 2 on both sides. You get W equal to 60. So that means, what is W? W is the width. So you know that the width is 60 now. So we need to find, let's see, let me verify with the answer I got here. Yep, the width is 60. Now we need to find the length, the remaining variables. Now remember, equation 1 is this. And we did simplify equation 1 to L. Okay. Now because this is already written in L equals something, and that's what we're looking for. So let's substitute W equals 60 into this equation so that we can solve for L. Alright, so I'm going to erase some of the step, make space. Let me erase this part right here, okay? So we know so far, we know W, which is the width, equal to 60. Okay. Our next thing to do is to solve for L. So let's use the equation, the equivalent form of equation 1. L equal to 50 plus W. This is equation 1, okay? Substitute 60 into this W. Simplify, we get 110, which is L. So L is 110. Now, I would like you to write a statement and explain what it means for the L and what it means for W, okay? So I would like you to write, this is equation 1. So I would like you to write, thus, the width is W, right, which is 60. Make sure you write the unit. So what is the unit? Meter, right? And the length is, what is the length? It's L, right? L is the length. In this case, L is 110 meter. Okay. So this concludes this section 3.2. Let me give you the homework set. Homework list, and this is section 3.2, number 1, number 3, number 15, number 17, so 1, 3, 15, 17, and the following problem. So this is a size problem, okay? So make sure you work on this one and this exam. This problem is solve the system of equation by the substitution method, okay, and the system is 2x minus, can't even write this, 2x minus 6y equal to 4, 3y plus 2 equal to x. Okay. So 2x minus 6y equal 4, 3y plus 2 equal x. And now you need to solve, okay? You need to show the step, but because this is a side problem, I'm going to give you the answer, okay? Answer. This, for this system of equations is, there are infinitely many solutions. Okay, so the answer is there are infinitely many solutions. Alright, this concludes section 3.2, and I will see you next time for the next section. See ya.